All right, page 5960. Any questions off of the first page?
11.
Number 11, got it. Number 11, we got x squared minus 25x plus 100. So looking at it, it appears that it's going to be perfect square. Why am I saying that?
Because they're all
25
perfect
is perfect
squares.
square and so is 100.
Well, the 25 is a perfect square. You're absolutely right. I don't know if that would constitute
okay,
that.
X minus 5x plus 10.
Yeah, well, the x squared is perfect square and the 100 is perfect square. So I think this is going to be x minus 10.
He didn't find
No, that's not going to work.
No.
All right, so that one won't work. So I'm going to do factors.
Unsquare everything? Why can't you
Yeah, 'cause-
unsquare everything?
Because if I add them up, that would become 20x, not 25x.
So, and
Well,
X
that's
squared
not going to work.
Gentry.
All right. Shh. They're both negative terms, 1 and 100, 2 and 50. That's not going to work. 4 and 25 doesn't work. 5 and 20 looks like it'll work. Then 10 and 10.
This could be
So the negative 5 and the negative 20 is going to work nicely, right?
Yes.
Yeah.
So I got x squared minus 5x minus 20x plus 100. What's my factor here?
X.
X. And then that gives me
X
minus
minus
5.
5.
Sweet. What do I factor out here?
Negative 20.
Negative 20.
Yeah, boy.
X minus
And remember that changes that sign. Everyone good so far?
Yep.
And my answer is x minus 5, x minus 20. Done. Cool. So yeah, I thought it was going to be perfect square, but obviously it didn't work.
Wait, can you factor out 5 and 20? Or take out a 5 from the 20 and then the 5 from the x minus 5.
Where?
Negative
What's
5
from
take out a
here?
negative 5 from the
It's already grouped. There's nothing more to factor out. Anything else on that first page?
14.
14. So 14. Yeah. 14. Let's see. 4x squared minus 20x plus 9. So I'm starting to think this might be perfect square. The reason I say that is because 4x squared is the same as 2x and 2x, and 9 is the same as 3 and 3. But it's not going to work for us that way again. Okay, and the reason it wouldn't work, so yeah, the 20 doesn't have to be a perfect square. It's just it wouldn't add up to the components. So I'm going to multiply those together. So I'm going to get 36. Being that's positive, that's negative. Both sides are negative. So the factors of 36 are as is. 13, 12, 4, 9, 6, and 6. What is it?
2 and 18.
Yeah, both of those work, both being negative. So. All right, common there?
2x.
2x, good. Common there?
Negative
Good.
9. Yeah,
There it is. Remember that changes both those signs, good. All right, so my answer is this. Done. Cool.
Anything else from that front side?
12.
12.
Is these like 2? What are they called?
So when it's two terms,
2 terms, yeah.
what you need to start thinking about is, could it be the difference of two squares? That's kind of my first go-to on this type of thing. And you look at it, 4x squared is the same thing as 2x and 2x, so that's perfect squared, and 9 is perfect square, which is 3 and 3, and it's the difference of two squares. So with that being a difference, it's going to be 2x plus 3, and 2x minus 3. Okay.
Could you describe like a situation where like there's the one on the test yesterday, the middle one? Because it didn't turn out like that.
But it only had a greatest common factor. So the one on the test, I think it was something like this.
Yeah, it was a number of parentheses.
It was like that?
Something like that.
I don't remember. So I think on this one you'd say, oh, I can do this.
Yeah, it was like that.
And then I have my greatest common factor. And then I have to see if that will factor out and this won't. Because that's not the difference of two squares. But you could have a scenario like this. So you had 6x squared minus 54. So you'd factor out your greatest common factor of 6, and then you get that. This is not all the way done because that's the difference of two squares. So this would become this. This doesn't factor down because that's not the difference of two squares because 2 is not a perfect square. I could be. I mean, they're all. So I mean, the rules on these really are: is there a greatest common factor? And then, do your magic number. If it's 2 terms, is it the difference of 2 squares? And then just kind of go off that. And the magic number is the first and the last number if there's 3 terms. So 13. 13, sorry. 4x squared minus 12x plus 9. It might be perfect square, but I don't know. I don't see it right away. So my magic number is 36. What? So I get negative, negative, right? Is that right? Because that's positive. And then 3 and 12, 4 and 9, 6 and 6. Which of those work? Both being negative.
4 and 9.
Or 9. Or 6 and
Wait a
6.
second. 4 and 9.
490 equals negative 13.
Oh,
Yeah, that
don't
equals.
listen to me. Mrs.
That would be 13.
Don't listen.
That gives me 13. That gives me the 12, right? So that's the one we want right there.
I was like, what? I
So-
never heard of
4x squared
Somebody
minus
made it.
6x minus 6x.
You got me too. I thought that's what.
Yeah, I was like, oh, that sounds good. I can't add today. All right. So this is fine, isn't it?
Yeah.
And if I factor out there, I can take out a positive 2, excuse me, and an x. So I get there, right? What do I factor out here?
3.
Negative 3. Make sure that changes both signs. So I have these in common, so I get 2x minus 3. What do I have left?
Plus
2x.
2x minus 3 as well. So that happened to be the perfect square one, right? But, we didn't see it right away. Of course, we can't add 4 and 9 together to get 12, but 15? What does 15 appear to be to you?
Greatest common factor.
Greatest common factor, does 4 go into 81?
No.
No. So no GCF there.
Wait, but
between
can you,
2 squares.
It's the difference of 2 squares. Why is that? 81 is a perfect square because that's 9 times 9. 4x squared is a perfect square because it's 2x and 2x.
so they,
So this will be 9x minus 2, or 9 minus 2x, 9 plus 2x, and it's done.
I don't understand the binomial.
Binomial, good term. Look at that.
Ooh.
It's so confusing. What?
All right.
Problem.
So number 16, they just wrote it out of order. So why don't you write it in this order? What do you think? Same thing? All the signs go with it? This might be perfect square. I don't know. So I'm going to multiply here and here, so I get positive 49.
Wait, but is it?
So it's positive, positive, and the factors 49 are 1 and 49 and 7 and 7. Which ones work? 7 and 7, right? So that gives me x squared plus 7, x plus 7x plus 49. So I have a greatest common factor there. And then I can factor a 7 out there. We have the x plus 7 the same. I'm left with x plus 7. So that one came out to a perfect square. So rewriting the problem in a different order is fine as long as you keep the signs consistent. Anything else from 1 to 17? Question for you. Who asked for 17? It's a binomial, so I look at it saying, okay, is this the difference of two squares? It's two squares, but it's the sum of two squares. There's nothing called the sum of two squares, so that is prime. It will not factor.
Wait,
Yeah,
what?
well.
Yes!
No, it
X plus
won't.
6 and X plus 6.
That gives you x squared plus 12x plus 36, but good try.
Wait, so can you simplify?
Yes!
down
I
that?
knew
X
it.
plus 6?
So I say the term difference of two squares. That's the key. Difference means you're subtracting. Sum of two squares does not factor. No matter how hard you want to make it factor, it won't factor unless there was a greatest common factor in there, and there wasn't. We don't have an x on both, and we don't have factors of 36 on both. So that one is just prime. It will not factor. Yeah.
Just like a real life application. So if there's a prime equation that you can't factor, like how do you?
So what we're eventually getting to with these is these are graphs look like parabolas, and things that work as parabolas in real life scenarios would be like the acceleration of a car in each gear is a parabolic function. Also, the braking distance of a car is a parabolic function. So that's actually one of the things that, in the more simplest form, is how would they determine how fast you are going in a car accident? They just find the initial skid part, and then they can track how far your car had traveled, and then they can go backwards and find out how fast you were actually going. Even with anti-lock brakes, there's an initial skid that does take place. It's only a small section, but you can see it on the pavement, and that's what they measure to. So those are real-life applications. But what would happen if it's not factoring? The parabola is doing really one of two things as far as what you'll ever do in high school math. It either opens up or opens down. Okay? Yes, there are ones that open sideways. You will not see it in high school. As far as, the path that your guys are on right now, you won't see it. I'm not saying that to be mean. I'm just saying, most of you are slated to get through pre-calculus. You probably will not ever see a sideways parabola. So that aside, that means that the parabolas that you do see, open up or down, if they don't factor, they can do a couple of things. They can cross the x-axis twice, they can kiss it once, or they don't have to cross it at all. If they don't cross it at all, that means that if you solved for x, you got x all by itself, you would have wound up with something called a complex number, meaning you would have found the square root of a negative number. It's part of the imaginary number system. So that's when a parabola doesn't cross the x-axis, which is this axis going this way and this way. If it does cross, but it doesn't factor, that means that it would become an irrational number. An irrational number, remember, is a number that can't be written as a fraction. So it's some decimal that goes on forever. So like, you might have came out with square root of 2. Square root of 2 you will never find the end of. You will get approximate but never find it. So that's where the parabolas that are factorable are all rational, meaning that all the answers can be written as a fraction when you found it. If they're irrational, they don't factor, but it doesn't mean it doesn't cross the x-axis. It does, but you find approximately where it does. Or they don't cross the x-axis at all because it's a square root of a negative number. So that's what we're leading to. So that's where we're going. So we will, once we're back from break, we will start actually graphing the parabolas, and you'll start seeing different things such as the axis of symmetry, which is the mirror portion of it. You'll find where it crosses the x-axis, the y-axis, how fast it grows, or grows in the positive infinity or negative infinity direction. But those are all things that we're working towards. It's just that the factoring is a key part of it, of getting there. Cool? Any other questions up through 17? Or can we go to the back page? Back page, what do you got? 18, you say? So 18. So we have x and y on 18, don't we? So 18. If you see x and y, the first thing you should be thinking about is there a greatest common factor? I don't have x on both of them. I don't have y on both of them. Nothing goes into 4 on both of them or 25 on both of them other than 1. So this looks like it could be the difference of two squares, meaning 4x squared is the same thing as 2x times 2x. 25y squared is the same thing as 5y times 5y. So this is the difference of two squares. So I'm going to get 2x plus 5y and 2x minus 5y. Done. Okay?
Is number 20 prime?
All right. I will tell you that number 19 is prime. It won't factor.
What? Yeah.
Wrong.
You're right, it does.
No.
Because your middle term has xy, and your last term doesn't have a y in it. It won't factor. All right, so let's take a look at number 20. Okay, being if you have x and y, the very first thing you need to think about is, can I factor out a greatest common factor? Let's see. 4, 5, and 6 have nothing that I can factor out other than 1, so that's not going to help me. I don't have x on all three terms, and I don't have y on all three terms. So greatest common factor, no. Okay? So, put your pencils down and watch here. What's missing from that? The y from the middle term and the y from the last term. Do you agree?
Yeah.
Okay, hang on. Just watch. So let me go ahead and factor this. My magic number is negative 24. You still with me? So that means I have alternating signs. And I got 1 and 24, 2 and 12, 3 and 8, 4 and 6. Let's see. Will any of those work? 1 being positive, 1 being negative. That add up to negative 5.
3 and 8.
3 and 8. Which one's negative? 8. Okay. So I'm going to factor this. So I get 4x squared plus 3x minus 8x minus 6. All right. What do I have in common right there? X, and I have 4x plus 3 left. What factors out of this? Negative 2. Good. Okay? So my answer is 4x plus 3 and x minus 2. That's for the black, correct? Being my original had this and this, I'm going to put a y here, and I'll put a y there, and I'm done.
Wait.
What is it? Let's try. Why? There's 2
I didn't say any other. I just showing you how for your second and third term have the y's in it. Factor, just ignore them. Factor what you know how to do, and then your answer at the very end you will put y back in.
But why would you put 2 y's when there's like 3 of them?
Okay, I like that. It's a great question. So this is the answer I'm claiming. So let's undo the answer. So I'm going to go 4x times x. I get 4x squared. Everyone still cool? Take a look. That matches there. Yes? Outside, I have 4x times negative 2, so I get negative 8xy. That doesn't really match there yet, does it? If I multiply here and here, I get plus 3xy. Oh, what's that going to add up to? Negative 5xy. See how it's working? And then my very last thing is here. I get negative 6y squared. Excuse me. So, if I combine this together, if I combine that together, does this match this?
Yeah.
So if you have your second and your third term has the y in it, ignore it for right now. Factor how you know how to factor. Once that factors down, put the y's at the very last spot on each of the binomial. It'll work. It'll work every time.
Would it be the same thing?
It'll work every time.
No. If there was a y on the first and the middle, then it would be.
If there was a y on all three terms, then you have a greatest common factor of y, which you pull that out.
No, just a first and the middle. That just the same thing.
It'll normally be set up like this. Okay. So the answer to your question, yes, you could have a problem like that, but I'm not going to throw one at you. That's why number 19 doesn't work, because you have that XY there in the middle. What else do we have up on page 60?
The random box
The random box thingy? So 27?
and 28. There's
27, 28?
confusing.
Alright. Alright. So this is M, this is M, this is N, this is N. And we want to find the area of the shaded region. So the area of the shaded region's this all out here, right? So if I found the area of the big square, that's M squared. If I found the area of the small square, that'd be N squared. How would I decipher that? Subtract, done. So then that breaks down to M plus N and minus N. Okay, because this is difference of two squares now. And then 28, find the dimension. So they're claiming it's a square of some sort. 28, they give us this, 25c squared plus 170c plus 289. Ew, yuck.
Ooh.
Okay, now, the reason I say ew, yuck is this. There's not a greatest common factor, so then my magic number would be 289 times 25. 7225. So let's figure out all the factors of 7225. No. I mean, 5, you're absolutely right. But we need to find all the factors of 7225 that add up to 170. Yuck. Okay? So, the next thing I might think about is this a perfect square?
Yes. It says
289.
Okay? So, break that down. I get 5c. So I'm going to have 5c and 5c. Agreed? 5c times 5c is 25c squared. Still with me? Square root of 289 is what?
Alright, 289.
Square root of 289 is? 17, isn't it? Okay. What is 5 times 17?
5 times 17.
That's what I said.
5 times
85. So 85 plus 85, is that 170? Uh-huh. So that's a goofier one.
That's it.
Yeah. So if you had something that was majorly huge like that, though you could go through and find the factors, it might be a little nasty because it's, I mean, okay, 1 and 7, 2, 2, 5. Okay, cool. Does 3 work? I don't know. Does 5? Yes, because it ends in 5 or 0. Does 10 work? No. I mean, you're going through a whole complex thing until you finally get to, 17 times 17 works. So, yeah, that's kind of a ew. Little ew. So a few things that we talked about is make sure as you're going through, your very first thing, is there a greatest common factor? If there is, that's what comes down to the very end. Okay, greatest common factor can be a number and or a letter. Correct? So, is there a greatest common factor? If there are two terms, is it the difference of two squares? Okay, if it is, then go for it. If it's the sum of two squares, then you can't go any further. Okay, so those are your first two questions. And then after that, if it's three terms, you multiply the last number and the first number. And factor. And find out what works. That's all it is. That's all we're going through. If it doesn't factor at all, it could be prime. What is B behind this snail?
That's his
The slime that he leaves behind.
Trail of poop.
no, it's like the slimy stuff.
Alright. There it is.
It's slime.
Alright.
That is not slime.
So guys and girls, let us
Take the quiz.
let's do the quiz. Your assignment, hang on, if you have your homework out, if you have your page out, one thing I want to show you on page 62. So problem 27, just do 27 to be like this. Problem 28, just do like this. Problem 29, just do like this. And if you look at them, you will notice I'm eliminating the equal sign. 30, just do like this. 31, just do like this. And 32. Notice I'm not writing equal 0, am I? So I modified this when I brought the 45 over. Notice if you look, take a look. So your homework tonight is page 61, 62, but you need clarification on those problems. Do it that way, please. And pass forward your homework. And here comes quiz.